Welcome back to the bench. It's time to progress on the Discrete audio amplifier design and build project. So as I alluded to in another video, I have the board all soldered together. You can see here I use solid copper wire to act as traces on these prototyping socket boards. Well, they're not socket boards. What are they? Perforated boards. Perf board, that's what I'm looking for. And interesting way I have these transistors mounted is because it's going to mount up to a heat sink. If you imagine the table surface as a heat sink, these will mount up this way onto a aluminum heat spreader, and that can bolt up to a larger heat sink. So yeah, here it is. I think I laid it out pretty nice, kept it fairly compact. Like I say, there are still some additional components that will be on here for short circuit protection, but since that doesn't really do anything to the amplifier when it's normally operated, I decided I wasn't going to put it on this because it's just extra parts to worry about. But anyway, I have some leads soldered up, so I want to power this thing up for the first time. Drum roll, please. I'm so glad to have this power supply on my bench because I can set it into serial mode, giving me dual supplies. Set the current limit. When you first hook up any circuit, it's always good to set the current limit to make sure you're not going to damage anything. I'm going to start at a low voltage of plus and minus 9 volts. I have the leads connected here, the power leads. Get that out of the way. Now, I don't recommend powering any audio amplifier without a heatsink. Even at idle, these transistors will be drawing about 1.5 watts, or dissipating about 1.5 watts each. However, I'm going to start at a low voltage. I don't want to go through setting up a heatsink. And I got my finger on the button to turn the supply off quickly if I need to. So I think we're okay. So go ahead and power this up. Make sure I got the leads hooked up in the right order here. And okay, powered up for the first time. And nothing really. Well, that light's on real. The LED's lighting dim. That's not really an indicator, but it can function as one. It's part of the current source. It's a kind of a reference voltage for the current source. And we're at a very low voltage, and it's not drawing any current, so nothing's going to get hot. Transistors are ice cold. So I'm going to bring the voltage up here slowly and see what happens. Okay, still nothing. Okay, we're plus and minus 15, which would be 30 volts across the amplifier. Doing nothing at all. I would think I would start to see some current. Let me find a screwdriver here. This control here is for the bias adjust. Let me wiggle that knob back and forth and see if it turns on fully. Okay, I went from end to end of this potentiometer and nothing. Yeah, that's not good. Well, let's go ahead and crank it all the way up, as high as this supply will take it. And okay, 32 volts. There's 64 volts across the rails of this amplifier. And I see the current source LED is lit. Kind of dimly, but I thought it would be brighter than that. It might be a problem here. And let me adjust this thing. We're still limited at 100 milliamps, so if anything takes off here, will be current limited. Though you have to remember that these capacitors have 64 volts across them. So if something turns loose, give them quite a jolt. Could burn something up quick. But I'm going end to end, and nothing. This thing is as as dead as a doornail. No heat, nothing on these transistors. I don't think it might be a little warm. Slight heat maybe. Nothing. Nothing's really warm. Well, obviously this is not working. I didn't test it out, I just soldered it together. I didn't really look it over or anything. So I'm going to turn the power off. Well, I was hoping this would work right off, but that's okay. We can go into a diagnostics mode and see what the problem is. Troubleshoot this thing and see what's going on. Okay, so this was a big fail. Let's see what the problem is. Let's see why this wonderful amplifier does not work. It's probably just, the connection wasn't soldered, or I got a component in wrong, or something like that. So you can look at diagnosing a problem with electronics in two ways. One way is an item that's already built, it was working and it quit. Or in this case, we have an item that was built from a kit, or something that was designed and built. Now if it was something that was working before and it quit, you would probably start looking for burned or discolored components, broken traces, bad solder joints, and then maybe start looking at the component level, checking components individually. If you're able to power it up, you would check voltages and things like that. But in this case, since it was built from a kit, well, it's actually, of course, it's a design build project, and it's not working. So I want to approach this differently. So the first thing I want to do is check continuity on my rails. This is the negative rail, and it should have continuity all the way up to the collectors of the output transistors here, the PNPs on the bottom, and filter caps, this resistor here, a couple resistors here. And of course this top rail should have continuity to the collectors of the NPN transistors, the output and the driver, some caps, emitter of this current source transistor, filter cap on the current sources here. Having problems talking today. This LED and this resistor here. So check all these continuous lines and make sure we're getting continuity. Same with the output node. The emitters of the transistors are on the output node through these resistors, and even this feedback line here has continuity to the output up to this resistor here. And like I say, go through and check all these lines here, make sure there's continuity, make sure there's not something that's disconnected. After that, I would power the thing up. Since we're able to power it up, I know that all these transistors do something even with the amplifier sitting idle. This is entirely a DC circuit, and when it's sitting idle, so all these transistors will have about 0.6 volts from base to emitter, because they're all conducting, they're all turned on a little bit, or they should be. The only transistors that won't are not in the circuit yet. Those are the short circuit protection. Those really do nothing in the circuit until there's an overload. But we don't have to worry about these because they're not here yet. So I'll go around and check the transistor voltages. Also, probably before that yet, I'll check currents. I know from my previous design videos there should be a certain amount of current flowing in these parts of the circuit. We have a certain amount of current in this input stage. The VAS stage will have 6.5 milliamps or so, and of course the output stage. Not so much worried about that yet, because if these previous stages don't work, the output's not going to work. And that's one problem with the solid state amplifiers, these hi-fi solid state amplifiers. The input has a DC blocking capacitor, but from that point on, this whole circuit is pretty much DC coupled. If there's something wrong in this stage, it's going to carry on and make things not work in stages down the string here. One thing nice about tube equipment, because there's certain voltages that have to be on the control grids, they have capacitors that block DC between each stage. So that kind of isolates each stage in its DC operation, so it's a lot easier to diagnose. So yeah, these are more challenging, but it should be pretty easy to locate the problem of why this thing is not working. So like I said, I'll start checking for continuity. I'm not going to do all of this on camera because it's hard to do this on this, with these small components on this board with a camera in the way. So what I'll do here is turn it over, grab my Rat Shack meter. It beeped at us saying hi. Set this for, I'll set it for continuity, I guess. And we'll check the rails first. So I got the supply removed. So I know that the rails are supposed to be on the collectors of the output transistors and the collectors of the drivers. So that's there. And let's see, I got this thing flipped over, so that's a rail there. So yeah, we're getting rail voltages there, and that rail should come over here. So that's looking good. So let me check over here. So I'll move the probe and check the rails for continuity over here. And this one loops around over here. That's good. Okay, we got the collector there. And let's see, that comes over here. So all the rails look good. So that's pretty much what I'm going to do. I'm just going to go around, check the ground, make sure the ground has continuity, and like the feedback and the output have continuity. And then I'll go to checking voltages. Well, on diagnosing this thing, I'm still at it here. I did find two mistakes, two soldering errors. And where's my pointer? Right where the emitter resistors come together and this output resistor and coil, there's a capacitor. They all come together at a point on the other side of the board, right here. And it looked good by eye, but what happened when I was clipping off the leads that were sticking up, I cut too low and actually separated that connection. Like I say, it looked good by eye, but I wasn't getting continuity. So the output here and the feedback was being isolated from the emitter resistors. So I fixed that. And the other mistake was this connection here, the emitter of the bias spreader transistor here, this was open. I soldered it, but I didn't get solder on this copper wire which leads to it, so it was an open connection. Yeah, but the thing is though, if that was the case, without this transistor here, this current source would pull this base towards the positive rail, and this amplifying transistor here would pull this base towards the negative rail. That would turn both output transistors on at the same time, so full current would pass through the rail here. But that's not what's happening, because we weren't getting any current through this amplifier. And after fixing these things, it's still not working right. So let me get it flipped over and powered up and take some measurements. Okay, powered up again. It's really not drawing any sort of current. What I'm going to do is measure from the base of this driver to the base of this driver. I should be getting the bias spreader voltage because I have these 4 base emitter junctions, roughly 0.6 volts each, so I should be getting around 2.4 to 2.6 or whatever, something like that voltage. And it's kind of hard to do this with this camera in the way. I gotta move out of the way here. I need to stand up. I need a better filming solution. So this is the base to base. No, base over here, right? 0 volts. And let me turn that off. I gotta get my eyeballs on this thing better. Base. Check again. Bzz. 0 volts. The bias spreader is off, collapsed. Well, there'd be some voltage even at full current. So apparently we're not getting current through that VAS stage. So what is, let's see, I need a ground here. Okay, from ground to this base, what is the voltage? Okay, that base is pulled all the way over to -31. Wait a minute, let me get these leads in the right order. So put the negative probe there. Let's see, this is the lower side. God, there's just so much crap to deal with. Oh, this is being pulled to the positive rail then. Okay, let me check the other base. That means, yeah, relative to ground, that's pulled to the positive rail. Yeah, that makes sense. Let me turn that off. So that tells me that the current source is probably working, and it's pulling these up to the positive rail, and this is turned off for some reason. I need to see why I'm not getting any. Oh, the air conditioner turned on. I forgot to turn that off. Sorry about that noise. But anyhow, so I got to diagnose this, see why this is not conducting at all. Okay, it's one day later now. I had to put it away. It was getting late last night. Had to get up early and do some stuff. So back on this project and finally getting somewhere. So here's what I found. So, like I said before, something was going on down here because the this current source was pulling the output up to the positive rail. And sure enough, when I looked down here, this whole trace was not even put on the board. My excuse for that error was when I assembled this thing, I started from the output and worked my way backwards to the input. Of course, this transistor was put in at some point. And when I got all of this done, I just put it away. It was Memorial Day weekend on a Sunday. Put it away, forgot about it. So then when I got it out to shoot this video, I soldered wires up so I can connect it to the supply, and this connection was off. So I put that connection on, or that trace on, hooked it up. It still don't work. I'm getting aggravated with this thing. Well, I looked at it again, and I noticed this little trace here from the collector to, you know, this part of the rest of the VAS stage. It was open. I was getting the same symptoms. So what was happening was, without that transistor there, it was, like I say, it was pulling the output to the positive rail. So when I made that connection, hooked it up, now we're getting somewhere. So I have it hooked back up to the supply. We have plus minus 32 volts, 64 volts total. Again, we're current limited. I have a speaker connected too. Quiet amp on turn on. I don't hear any pops or anything, but when I touch my finger on the input lead, oh boy, she's working. Picking up electrical noise. Let's put some music on it. Now, like I said, I can't really run this loud at such a high voltage with no heat sink. I have the bias turned down so it doesn't get hot. In fact, let me turn that off now. And put some music through it. It's first little play here. Okay, let's play some music into this thing. I have the music player, little junction board into the input of the Radio Shack perf board amplifier. Yeah, that's YouTube safe music. Botany Bay, band called Botany Bay. And didn't get too warm. I have the bias all the way down. I can actually hear a little crossover distortion. It sounds like kind of a dither noise in the piano music, but I can't really hear it in the other music. And I'm also hitting current limit some of the louder notes. But like I say, I can't crank this thing up without overheating the amp without a heat sink. I'm going to try another thing. I'm kind of curious at how low a voltage this thing will run. So let me crank it down here. Turn it down. Wow, it's running at 6 volts, plus or minus 3.1 volts as it's set now. Huh. I'll run it at 9 volts. I don't have to worry about a heatsink then. So I'll adjust the bias here, see what it sounds like. I took it up to 12 volts. I have the bias running a bit high though. It's at 70 milliamps. But yeah, it's just at 12 volts, it's just not going to get hot. So now let's play another sample here. Yeah, it sounds pretty good. Obviously, running at such a low voltage, if there's not enough volts across the current sources, they may not deliver the current needed, but I'll kind of experiment and see how it does function at lower voltages. It might make it a little more versatile. Good. I feel much better now. Got to this point. You know, all those videos, all that design work, designing all those parts and testing it. The meter wants to turn off. And, you know, it's putting it together and it wasn't working. A little concerning there, but yeah, I figured there'd probably be a connection or something not together. So great. Hey, pop a cold one for me. I don't drink, but hey, if you do, pop a cold one for me. So what's next on this thing? Well, just because it's working, I still need to test. You know, I need to check some currents and voltages. You know, make sure, you know, as a collection of parts put together, you want to make sure that everything's still performing as it was when I designed the components. You know, each stage, you know, went from the input stage to the voltage amplification, you know, setting the currents in those stages, to the output stage. So I want to check all that out. Want to do a power test, a normal distortion test, then a higher resolution distortion test, see how this thing performs. We need to talk about phase compensation. I just threw a cap in there so the thing is stable, but might need to fine-tune that, discuss how that works. It's all about closed loop phase stability and all that good stuff. Need to design a short circuit protection. Need to actually get boards made. You know, once everything's working just right, I need to get board professionally made for this. Of course, I have to do all the design work and all that. And if the end result meets my expectations, we can make a kit of this for people can buy. That's probably the hard part. How am I going to handle distributing this? I don't know how many people would be interested in this thing. But yeah, I still have a lot to go. It's been almost a year since I started this. When was it? End of June or July last year? Like I said, I'm not in any sort of hurry to do this. I got to do it in my free time. But yeah, it's just great to see this thing starting to come together. Well, like I said, this video is getting long. I'm going to wrap it up here, and we'll continue on in a future video. Thanks for watching. Hey Nick, gotta put you in the video or people get all upset. Some people really like to see the snicker. So, say hi. Really? Yeah.